Cosecant's the inverse of which function? Sine. So I don't need to find it. I just need sine. That means I need the inverse of cosine would be the secant. I'm going to try to cram it in here, and I'm not going to put my theta. Well, I guess I could. It's always hard to fit it on the screen. I'm going to draw a line here. All right. So what do y'all suggest that I do? If I got this value of cosecant, it's kind of like what we were just doing a minute ago. Yeah, let me find out where, I tell you what, let me go ahead and do this. They told me the tangent of theta was negative, so let's see. Where would the tangent of theta be negative? All students take calculus. What quadrants could this angle be in? Second or fourth, because tangent's positive in 1 and 3. So it's either over here or it's over here. Okay, so I'm just going to draw my angle like this. And let's think. Maybe I should think SOHCAHTOA here, you think? If I think SOHCAHTOA, let's see, cosecant is the inverse of sine. So wouldn't the cosecant be, and I'm going to write in red what I'm going to add in here, wouldn't it be the hypotenuse, the hypotenuse over the opposite side, because sine is opposite over hypotenuse. So if I flip those, I would have hypotenuse over opposite. Okay, so if it's hypotenuse over opposite, I know is my hypotenuse ever going to be negative? No, so let's put the hypotenuse as the positive 3, and I'm going to put my angle right here, so the opposite side would be negative 2. That makes me know what quadrant it's in, actually, because if my side's going down, if my y value is negative, what quadrant is this in now? Yeah, it's in the fourth quadrant, because over here, I would have had a positive value for my y.
Oh, yeah, and we know we had flipped our cosecant, the sine's negative, so it couldn't be in the second.
Right. Good, you're right. That's another way to know it's not second quadrant. So this is in the fourth quadrant. So actually, maybe I want to put my 3, maybe I want to change my triangle. I drew it like it was in the second quadrant, but then we realized because we were going down on the y value that it's actually over here. Negative 2, let me label in a different color since I've got red in there. Let me label in blue. So this side's going to be negative 2, and the hypotenuse is 3. So what am I going to have to do to find the other side that's right here? Pythagorean theorem. So we'd say, okay, this is a missing leg. I don't want to say negative 2 squared plus 3 squared is hypotenuse squared, do I? I got to say, oh, it's a leg. So negative 2 squared plus b squared is equal to 3 squared. So that would be 4 plus b squared is 9. If I subtract 4 from each squared, 4 from each side, b squared would be 5, wouldn't it? Okay, and so if I square root both sides, I'd get b equals square root of 5. So this side over here is actually the square root of 5. Let me put it up here because that's where we decided this was in the fourth quadrant. So now, if I've got my SOHCAHTOA written down, and I know it's in the fourth quadrant, all students take calculus. Cosine's going to be negative. Sine will be positive. Okay, tangent, we already knew tangent was negative. So let's go find our values. If here's the angle, sine is the opposite, which is negative 2, over the hypotenuse. We found that was, we were told that was 3, right? So the cosecant, we could have just flipped the cosecant to get the sine. I didn't have to actually do it that way, but it's just another option since it's there, right? What would the cosine value be, the adjacent over the hypotenuse? Square root of 5 over 3. And my secant, let's see, cosine's positive in that quadrant. My secant, I could just flip that, right, to get it, because it's the reciprocal of cosine. So it would be 3 over square root of 5, except that I got to rationalize it. So wouldn't it be 3 square roots of 5 over 5? Okay, it's kind of hard to read, so if you're listening to the video, you're going to want to listen to what I said and maybe backtrack a little bit. You can always rewind the video if you're watching the video to get this. The tangent is the opposite over the adjacent, or I could say sine over cosine. I'm going to go with the triangle here just because it's easier. So opposite would be -2, right? And the adjacent side is square root of 5, and when I rationalize that, wouldn't that end up being -2 square root of 5 over 5? Okay, so let me try to write that over here, -2 square roots of 5 over 5. I'll circle it so because it's kind of blending into my other work there. Wish that I could just extend the screen a little bit. And then cotangent would be flip it. I'm going to go right back. Let me circle in yellow. I'm not going to take my final product there to flip it. I'm going to flip there and end up with negative square root of 5 over 2. So that I don't have to rationalize what I flip. Okay. Come on, stop. In order to solve this equation, it tells us to find 2 solutions of the equation. Isn't the variable here the angle? That's what's missing, right? It's the only thing that we don't know. We know the value of sine, we just don't know what the angle is. And so what we're trying to do is find what angles have the sine of -1/2 for the part A. And they tell us there's two solutions. If we limit, we're going to limit ourselves to 1 trip around the unit circle. We're not going to go, oh, I can find an answer and then keep adding 360 to it to get another answer. They want to know in those 4 quadrants which 2 angles have the sine that's -1/2. Okay. Do we know anything about an angle that has a sine of 1/2 without us having to draw a right triangle? Do we know anything about that?
Yes, but I don't remember what.
Okay, it was 30 degrees, okay? So if you couldn't remember that fact, the only thing I could tell you to do is draw your 2 30, 60, 90, 45, 45, 90s and see which one of them you could get a half out of. And it would have had to been the 30, 60, 90. Because if you remember your labels, across from your 30 you called it A, across from your 60 was A square root of 3, and your hypotenuse was 2A. So if you look at the sine, the opposite over the hypotenuse, that would give you a 30-degree angle. So if it doesn't come to you off the top of your head, you might try doing something with one of these triangles. The reference angle is 30 degrees, right? But this is a negative sign. So don't I need to go think about the all students take calculus thing? Where do I have a negative sign? Yeah, in these 2 quadrants it would be negative, correct? Since it's negative in those 2 quadrants, that means that I've got a reference angle of 30 degrees first here. And wouldn't that be 180 degrees plus 30 for the angle? If I want to know what the real angle is, not just the reference angle. So I have to say, okay, if it's in that quadrant, that's 180 plus 30. That means that's 210 degrees if I'm working in degrees. And they want the answer in both degrees and radians, so we'll change it at the end. We'll think in degrees and change to radians at the end if that's okay. But there's another place that I have a negative sign, and it's over here in the 4th quadrant. And so if we had a reference angle of 30 degrees over here, wouldn't that be 360 minus 30 to give me the real angle? And the real angle is 330 degrees. So my solutions here in degrees, which angles have a sine of -1/2? 210 and 330. If I change those into radians, let's see, 180 is like pi. 30 is like, sure, pi over 6. If I wanted to get a common denominator, I could change this pi here into 6 over 6 pi, because that's still 1 pi. 1 pi over 6 over here. 6 pi over 6 plus 1 pi over 6 is 7 pi's over 6. So that's the degree measure there. And for 330 degrees, I said that was 360 minus 30. So what's 360 in radians?
2 pi.
2 pi, so it would be 2 pi minus pi over 6. If I want a common denominator, wouldn't 2 be 12 over 6? I'm going to write that in a different color so you can see what I did there. 12 over 6 would be 2 pi if I'm getting my common denominator of 6. So 12 over pi minus 1 over pi would be 11 pi on top and then 6 on the bottom. Okay, so that was the part A part. Actually, that was the part B. I couldn't read my equal sign because it's so hard to get these marks on here. This was supposed to be, A was positive a half, so I'll just call this B, and this will be A over here. We'll have to do that on the board. So on the board, I'll do sine theta equal 1/2, which is be probably a little bit easier.